You're listening to Coding Blocks, episode 90. Subscribe to us and leave us a review on iTunes, Stitcher, and more using your favorite podcast app.
And check us out at codingblocks.net where you can find show notes, example discussion, and a lot of other stuff.
Send your feedback, questions, and rants to comments at codingblocks.net. Follow us on Twitter at codingblocks, or head to www.codingblocks.net and find all our social links there at the top of the page. With that, I'm Alan Underwood.
I'm Zach.
And I'm Michael Outlaw.
Oh, I'm Outlaw. Jeez.
We're having too much fun with the names here.
Yes.
Well, okay, if he's Zach, what would you be?
Herb.
No, I thought about this. I think he would be Alun.
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 Does that make me sad or happy? If he's Jerzak, what does Alun make me?
Drunk?
Fair enough. Alun here. All right, as we do every time, the first thing we like to start off with are the reviews, and want to give a big thanks to those in iTunes. That's Paul Ketley, Rick Foyle, and Cole.
All right, big thanks to Stitcher as well. Thank you, President Dumazi and Gilderm.
I wonder how that one's supposed to be pronounced. The President Dumazi?
Yeah, I thought I did pretty good.
Yeah. No, I think we're all trying to skirt around like how they might really want that one to be pronounced.
I really don't know.
Yes. I did.
Light bulbs just went off.
Yes, got it.
Well, if you head to the show notes, you'll be able to see how it's spelled, and maybe you can illuminate me on.
We don't ever put these in the show notes.
What?
Do we?
Yeah.
Do we?
Yeah.
Okay.
Mad respect, yo. Mad respect.
Man. All right, then.
How else are we going to thank people?
That's a good point.
All right. Speaking of mad respect, today we're talking about Git Workflows. And we're going to talk about a couple different types and a couple different things. But first, we want to talk a little bit about why we're talking about workflows. And a big part of that, a big part of the reason people even talk about Git Workflows overall, and why they didn't talk so much about Subversion workflows or like Visual Source Safe workflows, is that Git is a toolkit. And we don't talk about Visual Source Safe.
There was no workflow. Lock file, nobody else touch file, unlock file.
No, that's not fair.
Touch it.
It did have, there was I would say there was a quote workflow about it, but it was like a library system. You check the book out, you have the book. No one else gets that book until you bring it back.
Lock file, unlock file.
Right.
Anyway, sorry,
yes. That was his workflow.
Everybody ignores those locks, though. You could change stuff, and you just email the person, be like, "Yo, you still got this thing locked. I edited it anyway, so you got to deal with it now."
Well, there was that.
That is truth. All right, go ahead. Sorry.
So the reason that we talk so much about Git workflows and why we've been using Git for so long, and probably a big part of it's the reason for its longevity, is that Git is a toolkit. It was designed as a set of programs that you can chain together to kind of manage your code. And it's not so opinionated, but a lot of people have had opinions about it. And I've got a little list here of kind of controversial topics that you may have heard of if you are deep in the Git scene. Things like branching strategies, tagging strategies, rebase versus merges, how you handle like dependencies, whether it's like subtrees or submodules, commit hooks are kind of controversial, pull requests, forking versus cloning. That's just like a little like list off the top of my head that people have really strong opinions on, and depending on where you work or what experience or bad experiences you may have had, you may avoid some of those like the plague and favor others. So I took a little look at the source code actually because when I read this thing was like a set of programs, it got me wondering like, is Git add a totally separate program from like Git commit? And so I went and I found the GitHub mirror of the code. It does look like they've got kind of an interesting setup where they use that as kind of like a publish-only version of the source. So I don't know where they maintain like the real kind of what I can't even say real because it's decentralized, right? But somewhere they have like a hidden repo where the people actually kind of contribute to, and they publish to GitHub. So if you want to go see it or work with it, and then you can find instructions there if you actually want to contribute. But if you do look at that source code, you'll see a bunch of C files, and so you'll see a file for like commit or add or bisect, but they aren't separate programs. They don't have their own main method. So there's some sort of orchestration going on there that I didn't really get too much into. But I did see a ton of other files, like things with PL extensions and Pi extensions and SH, and there's web servers in there, and there's testing executables, all sorts of crazy stuff that I'm not used to seeing in projects. So I thought that was really interesting. When you think about it, it's really not one executable. It's a lot of different things. It includes the documentation. There's just a lot of stuff actually checked into there. And yeah, it's really complicated. And so, I mentioned those topics above, but another reason that people talk about it a lot is that your source control workflow is a really big part of like your day-to-day life, right? What you do when you get a ticket, how you kind of interact with your ticketing system, and even your emails and your coworkers, like all this stuff is kind of built on and really kind of modeled with Git. So it has a big impact on your day-to-day quality of life. And so ideally that's going to align really well with how you're actually using it. You don't want to be fighting your branching strategy day in and day out.
And we'll get into some of that, but it's true. Like, it can totally change your quality of life during the day, depending on which strategy you choose, based on the pros and cons that we'll be talking about.
And your role within the team.
Yeah. Says the guy who's in control of a lot of the Git stuff that we do.
Yeah, do you guys, I don't know if we talked about this back in episode 3, but have you ever looked to see where Git got the name Git?
No.
Oh, I remember something. It was like, I remember reading something about it. It was like just random gibberish or something that he made up.
So there's kind of 4 reasons that are kind of given now, and you'll see this in Wiki. It's actually in the GitHub repository. One reason is that it's a random 3-letter combination that's pronounceable and isn't used or wasn't used by any other Unix command. So that's like the kind of name I would come up with. But there's also the notion of this stupid, contemptible, and despicable kind of simple. Like when you think of it like the slang, if you call someone like a lucky git, then there's that. And so global information trackers if you're in a good mood. And then there's the 4th response, which all this kind of Linux profiles is like, there's kind of 4 reasons for it, and depending on my mood, that's the one I kind of think of it. But the 4th one is the beep, idiotic truckload of beep, when you're having a hard time.
I kind of feel like the global information tracker, like, you remember that old meme from like years ago? It was like kind of like a video kind of meme. I guess it wasn't really a meme, but it was a joke meme of like, when Apple designs a product, it's like, it's very simple. It's iPhone, just a picture, one word, right? And there's no versioning. It's just iPhone, right? But then there was like the Microsoft iPhone, and it was like Microsoft Productivity Edition iPhone, Microsoft Professional Ultimate Upgraded Edition for 2018 iPhone, right? And it was like, well, if Microsoft were to create name Git, it would be the Global Information Tracker.
Yeah.
Microsoft.
Yeah, that sounds about awesome. A lot of links to those guys in the source code, so you can check that, or in the show notes, so you can check that out.
All right, so let's dig into some of these workflows, and let's start with the centralized workflow. So this is going to be your most basic of the workflows here. And the idea is you're going to have a main repository that's centrally available, and everyone on the team is going to commit their changes directly to master. You're not going to bother with branches. Nobody's got time for that. It takes too much effort, whatever. You can't be bothered to type in that extra command. You're just going to commit your changes directly to master and merge them in. Now, in this workflow, that central repository is treated as your sacred, immutable source of truth, right? You're not going to go rewriting history on that. That's it. So we'll go through some examples. Now, we won't go through example commands for all of these, but just to kind of set the stage, right? I wanted to go through some of these. So you'll initially create that central repository, but then as the developer, you're going to clone it locally using a git clone. Then you'll make and stage and commit your changes like you normally would. So, using your editor of choice, you'll make the changes, then you'll git add to stage them, and git commit to commit those changes. And then when you're ready to merge the latest changes from the central repository in, then you'll do a git pull to pull down the latest changes. Now, if you're a Subversion user, this would be similar to an SVN update. Would I have a typo? All right, so it threw me off, sorry. So then Now, if you want to, we've talked about the rebase option. If you wanted to keep your changes at the tip of the history, then you can use a git pull rebase or git pull -- rebase option to take all of your commits and merge in the latest from the remote master, move all of your commits to the tip of that history so they're all nice and together, right? And so that it flows in line and they're not intermixed in between, right?
Yeah. So what he's talking about specifically for people that don't have experience in this is if you were to do some work on your branch, commit that, do some more work, commit it later, do some more work, commit it later. When you go to pull in the remote repository into yours to merge it in, if Mike had also done some commits in that time frame and Joe had done some commits in that time frame, it's going to line them up with the time that those commits happened, right? So all mine are going to be intermixed with all theirs, and so it won't be easy to see what the logical trace of work being done was, right?
Yeah.
Because I wasn't working on those files when Mike was working on them. I was working on them in my own time. So what he's talking about is if you then pull that stuff in and you do a git rebase, what it'll do is it'll take all your work and put it at the very end, right? Like it'll say, hey, these were the last ones that went in, and it'll be in the order that you committed them in. So you'll be able to see all your changes together.
So to just quantify what you said, if you and I worked on the same file and we had commits that were within a minute of each other, we each had 2 commits, so a total of 4. Then the difference is if I didn't do a git rebase, then the commit order in the history could be Alan, Michael, Alan, Michael. But if I do the rebase, then it could be just Alan, Alan, Michael, Michael, which is describing what you're talking about.
Exactly. And that's really helpful, by the way, when you go back and you look at history on a branch or a pull request or anything. Anytime you're looking at history, it's a heck of a lot easier to look at it and say, oh, well, that was the first change that Alan made, the second change, the third change, as opposed to, wait, Alan made a change and then Michael made this, but how does that fit into the plan, right? So it's extremely helpful when you can line these things up.
And I did want to point, oh, sorry.
I was going to say, have you ever seen a funny situation where you like look at source control and like if you're not so used to Git and you think like, okay, there have been no changes since yesterday, so I don't need to do a pull. And you don't realize that in the meantime, someone merged something in, but it was a change they made like yesterday. And so the change snuck in back into history and it's not at the top of the pile because they didn't rebase.
Yep, definitely.
Yeah, so I mean, some of these commands, I'm kind of glossing over the commands because I didn't want to get too deep in the weeds with commands. So like, just know that there are like there's extra options and parameters to add on to these commands, but I'm just giving you like the high level git add, git commit, pull type of options, right?
Yep.
But when you do the pull, that'll allow you to handle conflicts on a case by case basis. And then when you're done with handling any conflicts, if there were any, then you can push your changes using a git push, which again, if you're coming from a Subversion background, that would be similar to a SVN commit option, right? So why would you use this? What are the pros? What are the cons of using the centralized workflow? Well, right away, like this one is the stupid simplest version of any kind of workflow that you could use, right? It's easy to understand workflow, especially for a team. If one or more people on your team are transitioning from Subversion, then this makes it simple for them to understand the workflow, right? And honestly, you might be thinking to yourself, like, why would I ever use this project or this workflow? We would never use this workflow, right? Would you guys agree to that?
Yeah, except for your next bullet point.
Okay, but we do use this workflow. This workflow is actually great for small teams and or small projects. So if there's going to be few contributors or few contributions to the project, then you might not need all the hassle of something else. Even in your work environment, you might have a large team of people that you work with, and that's why I say we actually do use this workflow. But on some of the smaller, parts of an overall application, it's like, okay, that one's in its own repository and it rarely changes, so why go through all the process, right? So The cons to this workflow, though, is that if the team does scale up, or I should say, when your team scales up, resolving conflicts can become a huge burden on the team. So another way to say that is like as the number of contributions or commits to this repository happen from various places, then that's where it's going to become a problem. And you're really not leveraging Git's distributed nature with this scenario, right? But like I said, if we go back to when would the seasoned Git guru might want to use this, right? The small projects that don't change. There's no sense in creating extra process when it's not necessary until it is.
Hey, so real quick, I want to go back on the conflict thing, because if you haven't worked in source control a lot, you probably don't know exactly what we're talking about here. The conflicts happen when two people change the same file, essentially, right? And you got
the same area of the same file.
The same area, and yeah, exactly. Like if you're both playing around line 20 and 21, then it's going to have a hard time resolving those, and it's going to ask you to say, hey, make an intelligent decision here on which one of these should win. Or
you're presuming it's going to be an intelligent decision,
or maybe not so intelligent, but it could also be, hey, maybe neither one of these win when the two are brought together, and you're going to have to sort of modify this to make it right. And the thing that I guess what I wanted to point out with this was the conflicts happen. There are tools that you can use to make your life a little bit easier. Like I use KDiff on mine, and it's a 3-way merge tool. So there's other ones out there, but just be aware that these things exist. And Visual Studio actually has a very nice one built in.
Yeah, I was about to say some IDEs might already have this built in.
Yeah. So
depending on your IDE of choice. Of course, if you're going to tell me that Vim is your IDE of choice, then you might be out of luck.
But it's worth pointing out. I wanted to bring this up though, because one of the key benefits, we're going to talk about the workflows even more in a second, but one of the benefits of using Git is you can have truly concurrent development going on, right? And that's awesome. But with that comes the conflicts. And so knowing how to resolve them, and then also knowing these workflows will help you either get away from having to deal with them so much, or allow you to handle them just when they come up and it's not that bad.
Actually, that's another point too. We didn't really discuss this at the top when we were talking about why to discuss this, or why to discuss the workflows, or maybe we did and I didn't over
busted
or whatever. But yeah, thanks, Jeff. But it's helpful. It's helpful, kind of like what you were saying. You should know when to use which of these workflows and why, so that it to avoid it becoming a burden.
Yeah.
On the team. So it is good to know, because you will use. It's not like one size fit all in your entire organization. You'll use multiples. And
honestly, I mean, I think the reason we came up with this particular show is, one, Outlaw loves Git, and I think all three of us are pretty seasoned with Git. I wouldn't say that we know the Bible inside and out of Git, but we know how to work with it, right? But we've experienced a lot of pains with Git, depending on the types of projects we're doing, the whether or not you have support multiple or whatever. So that's the reason why we thought this was an important one, is because we've sort of learned through some massive pains which ones work and which ones don't.
Well, I still think this one works out really well, like especially if you're like a solo developer working on like a GitHub project, like for like a side project. I think this is a great place to start, because it's low overhead, but also because it can be really tricky to like name branches and do these other strategies if you don't have like a clear focus and you don't have this other process around like tickets or like clear cut feature names. Like if you're just doing stuff or cleaning up the UI, then it kind of stinks to have branches named after that, because it kind of implies that if you have like a cleanup branch, that means that you're not cleaning up other times. And so the names get kind of messy and trip you up. And so I think this is like the one I start with when I'm a solo developer. And same thing with like with Git, QIT definitely started with this method. And as more people started contributing, it just got unwieldy, because it got really hard to tell like what's going on. And sometimes someone would be kind of working something or wanted to ask about something. And if you didn't have branches, you just couldn't really do that. And so I think the branching strategies kind of start as an evolution of this. Like this is almost the base starting point for Git. Like this is the Subversion standard workflow. and we Git kind of came along to add functionality on top of that, but it still kind of supports that basic centralized pattern.
That's a great point. Hey, real quick poll here. Do you prefer command line or do you use tools like Visual Studio or any one of these other Git tools out there?
Command line.
Command line.
Command line. All right.
And the reason for me is just like, I think the tools are great, but it makes me kind of nervous to not really know what the tools are doing. And I learned Git from a command line basis. So I like to know what I'm actually kind of doing on a very granular level. And I know like even the tools, like you'll hit say merge and you'll watch where it actually generates. And it's like merge dax sf, underscore, whatever, like weird stuff, pipe it to this. So like, oh wait, I don't know about any of that. I need to be able to fix this when I inevitably get myself into a terrible mess.
Yep, I completely agree. Although I do use the merging, the visual merging tools. So KDEF or Visual Studio or whatever. I hate digging through the files, looking for the alligators and all that kind of stuff. Like I don't want to deal with that.
Yeah, I still, it hurts my soul to think about like large, I guess not maybe medium organizations kind of relying on Git for merge conflicts, because they help you line by line, but they don't really help you with like intent or context. Like, so if you imagine like you've got two developers on a small project and one of them goes to a web page that says, you know what, the title doesn't really match with the description of this, the paragraph underneath it. Let me change the title so it's more accurate to reflect what's in the paragraph. And then the same day, the same time, and the developer's like, you know what, this paragraph doesn't really match the title. Let me change the paragraph a little bit to fit the title better. And then you merge it and things totally went sideways. But it's always amazed me that this doesn't seem to come up as often as I would think it is. Like I thought, like when I first heard about Subversion, I was like, it's never going to work, guys. But it totally does work out really, really well, 99.99% of the time.
Right.
Yep. So let's move on to the feature branch workflow. So like Joe said, the centralized one, we'll call that the de facto standard Git workflow, and then the feature branch is really going to be, even though we were kind of saying that the centralized is the de facto, the feature branch is what everything else is going to build upon. So this one is, you're still going to have that master branch, but all of your development for new features are going to be performed in a dedicated feature branch. And this will allow the developers on your team, it'll give them the ability to iterate on a feature without the need to modify master until the feature is ready, right? So hopefully this means that master never gets incomplete code, right? Nothing is merged just because you're going upstairs to change computers, Joe.
Yep.
So
convenient.
Or which makes it advantageous for continuous integration and continuously deployed environments, right? So you could also refer to this as feature encapsulation. And this feature encapsulation allows teams to utilize pull requests, which is a great opportunity for the team to discuss and review the code before it's merged into master, right? And like I said, this feature branch workflow is going to be the building block for other workflows. Not necessarily all, but several. So real quick, we're going to start from master. So we're going to git checkout master. We're going to create a branch off that. So we might do like a git checkout -b my new feature. And then same as before, we'll make our changes, stage them, and commit using git add, git commit, push them up after we've merged in whatever changes were from the central repository or the remote repository. So we'll push those using git push. And then whatever the tooling is for our repository management system, we can use that tooling to create a pull request. So like a GitHub or a GitLab or Visual Studio Team Services, Bitbucket, they all have the concept of a pull request where they will allow you to visually see what's going into, what's changes are being requested. Right? And if there were conflicts, you would have had to address those before your pull request can be merged in. So you will have to handle those locally and then push that back up into your feature branch on the remote source. And then, what did I put here? Oh, if another developer, another advantage or feature of this is that if, say, Joe and I are working on the same feature together, I can push that feature branch up so that Joe can pull it down and we can iterate on the development of that feature together without interfering with master or anything like that. So, it allows us to each have our own copy of it and iterate on it together. So the pros to this workflow is that it allows, or I should say, it promotes code review and team collaboration, right? And that can be taken in multiple ways, right? There's not only just the PR aspect of the code review and the team collaboration, but there's also the ability, like in the Joe and I are working on the same thing example, right? Like we can collaborate on that code together, right? Well, we can iterate on it together. And then there's the pro that this is going to keep your master stable while you are developing on this new feature branch. So the new feature has all the code that's incomplete and it doesn't get merged in until it's ready. Now, the cons to this, though, is that if you have long-lived branches, those long-lived branches are going to be a higher risk of merge conflicts. So your best bet is to keep your features small so that you can merge your feature branches often.
How often?
I mean, that's going to vary, really. I mean, there's no set, I would say, but I guess a big factor is going to depend on like how often the repo changes anyways. Like if the cadence of that development, if it's an open source project, and the cadence of it is it's not seeing a change but like once a week, then okay, fine. If you got 2 weeks behind, you're probably not going to miss a whole lot, right? But if you went 3 months, it would be a problem. Whereas if you're on like a typical work kind of repository that's changing massively every day, and you got behind by a week, you could be in trouble. Forget about if you got like a month behind, then you'd be in serious trouble. So that's where these long-lived branches can be problematic. So when should the seasoned Git guru use this type of workflow? Well, my joking answer here is like, well, always, right? Like, and I say that kind of serious, kind of not serious, but kind of mostly serious, because like I said, this is going to be a foundation or a building block of other workflows. So whether or not you're using this one by itself or not, you're probably going to use aspects of this workflow. This is definitely going to work out better for large teams or projects when compared to the centralized workflow. And yeah, I already said that it was a building block.
So a couple of things here. The thing where it's used by large teams or whatnot, this goes back to what Joe said a minute ago about when you have ticketing systems, it's a whole lot easier doing these branches, right? Because you have a ticket that you're working on, and it could be ABC-1, right? Then you kind of have like this outline of what to name your branches, and so it's kind of easy to line up your code with whatever the requirement was. And so that sort of eases it. Like what Joe was saying earlier is if you didn't have something or some sort of process in place to say that, this feature is ABC-2, then you're probably going to name it my clean feature dash, I don't know, ABC, whatever. You just start randomly creating branch names, and it can kind of turn into a mess, and it's sort of hard to keep up with all that stuff.
It's not necessarily a bad thing, though, to name your branches off of the features. I mean, my personal preference is definitely to go off the ticketing system, because then you have the ability to track it back to whatever the source is, whether that be manually or if you're in, like, for example, if you live in an Atlassian world entirely, where you're using like Bitbucket and Jira, then those things can be tied together to where just the mere mention of the ticket name in the commit message or in the branch has the ability to allow a link in the UI back to the original ticket.
Right.
And Visual Studio Team Services has a similar feature. So that's why my preference is to go by branch name. But if you're not in a large enough project where you were using that, then naming it off of the feature, like maybe new left nav redesign, might be your feature branch. As long as it makes sense and there's some consistency in it, then that's where, consistency is what's going to matter.
I agree. And now the other thing I did want to bring up was the whole multiple people working on the same branch. So that's awesome, right? I create a branch locally, I push it up to the origin, which, by the way, that is sort of the de facto name when you're talking about Git for the centralized repository is the origin. But
Convention.
By convention. Yeah. You can name it whatever you want, but by convention, it's origin. You can push that up there, right? So my feature branch, and then Mike and Joe can go work on that thing, and we can all pull it down, and we can all work on these, and anytime we push up changes, next time I pull them, I'll see their changes, right? But you have to be careful with that because we talked about the rebase thing earlier and that it lines up commits. When you're working on a shared branch with other people, rebasing rewrites the history of that stuff, and you can just get into a world of hurt with that, right? So you have to be at least mindful of what some of these things are doing when you're going to push them up, right? If you're going to rewrite history on something that's already a public branch, you could be causing a lot of problems for other people. So just be aware of that.
Yeah, a couple of things I wanted to mention too. A lot of people, I went looking for Git opinions when I kind of read about it not being that opinionated, and boy, I found them. There's a whole website's like titled like Git opinions and whatnot that like offer some strong guidance on some of those controversial topics. And some of the ideas that I saw, we'll have links in the show notes and resources we like. But people advocating for initial prefixes, especially if you have a system like Visual Studio does this. I think GitHub does too, where it will kind of see slashes in branch names and treat them as folders. So you could do like your initials, JZ/ and then ticket number or then feature name. And that way it kind of scopes it to you and makes it easy to kind of see like what branch kind of is owned or been created by who. And it's easy to see that in the pull request too. So I think that's pretty nice depending on your editor, and maybe initials aren't good enough if you got a big team, but it's still kind of cool. And I also wanted to mention too that I looked up specifically on the cadence, and a lot of the strongly opinionated Git users, if you have a Git website, like you're probably strongly opinionated. But I was really surprised to see so many people reference checking in, or rather committing and pull requesting your branch daily.
Really? Just pushing it to the origin?
Yeah, getting it pull requested in.
But for like, what was the cadence?
They didn't specifically talk about cadence. They just said every day.
So
they're talking about like a work situation where there are commits going in every day.
So non-code complete. That sounds like the Visual SourceSafe way of doing things back in the day, where it's like get all your code in by the end of the day. I don't understand that in the Git world. Personally.
I would never advocate for merging code in that isn't complete.
I agree. Just straight up. I totally disagree with doing it just because it's the end of the day.
Yeah, that seems artificial.
Yep, I agree. There are some techniques for kind of working around that. So rather than checking in something that's not done, you would like either deal with a feature flag or some other way of kind of doing that. But the idea there is mainly just to avoid those long-lived branches. So you want to avoid having a situation where you've got a ticket that takes you 3 weeks, and you either subdivide that into multiple tickets or multiple features, or do ideally some other way of doing it. That said, I mean I don't do that. Like it depends very much on the case, but like I definitely hate long-lived branches, but I think 2 or 3 days isn't going to kill anybody.
Yeah. Like I say, that's why I was trying to say that it's really going to depend on the cadence of how many new things are getting merged into that repository, where the length of time is going to matter. But for those that aren't familiar with feature flags, I don't know if we've ever discussed that here, but the idea with feature flags is you could have a branch of code, maybe you're working on it, but unless you know the special way to turn that bit on, it won't get executed. So that could be a precompile directive so that the code compiles with that functionality in use. Otherwise, it's not even part of the compiled output. Or it could be something as simple as a command line parameter or maybe a query string parameter that triggers that execution of that code. But the idea is you can slowly but surely leak in your feature into the main code base. In this case, let's just call it master, without it impacting anything else.
Yep. One other thing before we move on to the next one, the long-lived branches, we've mentioned it many times, and like Mike said before, that truly just depends. Like, does it matter if there's only one commit happening per month? No, I mean, you could probably go for a whole year and it wouldn't matter, right? But the way to deal with long-lived branches, typically to cause the least amount of pain, is to constantly, as frequently as possible, pull in the origin stuff, right? Merge in the latest changes from whatever you branched off of in order to do it. Now, that doesn't mean it's going to be painless, but it does mean that you have less chances of conflict as you bring that in, or the conflicts that you get will be easier to pinpoint because it'll be a smaller subset of code that you're dealing with, right? If you go for a month before you merge in the latest code, then you could get hundreds of conflicts, and you're not gonna be able to figure out the scope of what all changed. So,
well, that's not always going to work, though.
No, not always.
That's why this is a great segue into the next workflow, which is affectionately known as Git flow. So how this works is we're going to build upon the feature branch workflow. So similar to that idea, but instead of having just a master branch, we're going to create additional branches. And these additional branches are going to have very specific uses and purposes. And not only do they have specific purposes, but they're going to have specific times when those branches should interact with other branches, right? And the master branch here will represent our officially released version, or versions, I should say. We will create tags off of master for the versions that we release, right? Typically, in this workflow, you will have a develop branch, and that is the branch that all of the developers on your team will use to iterate on the next version. So what I mean by that is, in the feature branch workflow, we created a branch directly off of master. But in Git flow, we're going to create our new feature branches based on develop instead. And when it's then when we're done with that feature, we'll merge that into develop, back into the develop branch. Then when we feel it's time to release our branch, we're going to base that off of, we're going to create a new release branch based off of develop. We might do this because either our schedule dictates that it's time to release a version, or maybe we have compiled enough features that it's time to release. But whatever our reason is, we're going to create a release branch based off of develop branch and use that. So we'll do all of our testing off of that release branch. And if we find anything that needs to be fixed, we will apply those fixes to the release branch. We'll just apply them directly to the release branch.
So what we've said now is you've got develop, you branched off develop to your release branch, and then any fixes that are going to happen, you're going to basically just check those, commit those straight into that release branch.
Yes. So now, once the release branch has been tested and we have certified that it's ready for release to production or manufacture, whatever your choice of term might be for your environment, we will merge the release branch into both master and develop. Now, you might ask, well, why would we go back to develop? Well, any fixes that we found in that release have to go back to develop. We don't want those to get lost. Now, we've merged it into master. This is when we will take the opportunity to tag that version number. Now, so far, we've talked about 3 branches so far. We talked about our master branch, which is our default, our develop branch, and then this release branch. And technically, now that we've merged the release branch back into master and develop, technically we don't need it. So we could think of that branch as like short-lived. It's going to come and go over time. And there's going to be another short-lived branch like that, and those are going to be for hot fixes. So if the production version, i.e. master in this case, if we notice that there are issues with master and we want to immediately address those without waiting on a new version, then we can create a hotfix branch based off of master and make our changes there, test them, and then merge that back into master, right? This is the only branch that we're going to make directly based off of master. Everything else is typically going to be based off of develop or possibly the release branch. Oh, and I forgot to say this hotfix branch, we will merge it into both master and the develop branch, right? And again, we will tag master to update our version number. Now, in this scenario, we've kind of already laid some groundwork there for commands, and I was like, it's going to get way too lost in the weeds if we start going over all the commands for every one of these workflows. So really what I wanted to point out here is we haven't really introduced any new commands. It's the same kind of commands that we always did. You're going to get the repo by doing a git clone. You're going to stage commits using a git add. You're going to commit them using a git commit. You're going to do your git checkouts, your git pull, git push, like all of the same commands that we talked about before. You're still doing all of those. So there's nothing new here. So,
but the only difference now is where you're doing these commands, right? Like whether you're branching off master, whether you're branching off develop, or where you're committing to and where these pull requests are happening from. It's literally just changing places, right? Like where you're initiating a lot of these commands.
Yeah, and to that point too, I'm going to have links in the show notes that will point you to places that will list out if you wanted to see very specifically, every individual command and what it'll look like. Because I thought that might be a little bit difficult to keep up to while you're listening on your commute or as you're cutting the grass or whatever, riding your bike or whatever, Okay, so.
I do want to call out the tags, though. The tag is the major difference, I think, between the previous and this one. And I think the tag is really important from an organizational level because that's really what we've added here is we've kept the feature branches. It just we've kind of organized things into separate branches in order to kind of streamline our release process because it basically models the real world. So I did want to go over real quick, as a developer, when would I merge my pull request directly into master?
In this workflow?
Yeah.
Only on a hotfix.
Yeah, hotfix only.
Okay, hotfix. When would I merge into develop?
When your feature is done.
Yep.
And what was the third? I missed that. Merging off of a tag.
We didn't talk about specifically checking out the tag.
Okay, I think and the only I kind of think of that as being a third, but the idea there is if you kind of have a hotfix out there and you need to kind of apply a specific hotfix to something that's not in master, for example, if you've got more than one concurrent release, which is something we're about to get into, but things get kind of hairy because in that case you would have to go and find the appropriate tag for the server that you need to update, make your change on top of that tag, and commit that in there, and then somehow get that back into your master development branches, which is, sometimes that's a change that you don't necessarily want to get in there. And so that's where Git flow gets a little kind of gross. And I do think a lot of people kind of think of Git flow as being the answer, this is how you do it. And they start kind of running into some of these problems, especially with the tags, and things get a little messy because Git flow doesn't line up perfectly with their business. And that's why I think that Git flow isn't a one-stop shop kind of answer. And we're going to look at a couple things here in a little bit that are going to deal with that a little bit better.
But it does have a lot of great benefits. So I don't want to beat it up, but so to go over what the pros of the Git flow workflow are is this is ideal for projects that have a scheduled release cycle, and great for projects where you only need to support one version. So for example, this might be your company's website, right? Like, typically you're not going to have multiple versions of your company's website running concurrently. Now, if you're thinking of like a Facebook or an Amazon, they might A/B test some features, and they might have like multiple versions depending on regions and things like that. I'm not talking about like the gigantic, enterprise corporations like them. I'm talking about more like the small business owner that makes up the rest of the economy.
And this is really important. One version or maybe two versions, but a fixed number, right? Probably a very small fixed number of versions is where I think this would work the best.
I think one. I really do think one.
Yeah, that's probably true.
And we can continue this conversation when we get past
to
some
the
of the
next
other
one.
ones.
Right, yeah.
So put a pin in that one, and we'll come back to it. So other benefits of this, all the benefits that we talked about with the feature branch workflow are still here because we built upon it. So the idea of the pull request and the isolated feature development, the collaboration, all of that still here. There's also tooling that exists specifically to help streamline the process of using Git flow. So if you wanted to get like all in, if you've heard everything we've said so far and you're like, I'm sold, there's actually command tooling that you can install. So even from a command line, it doesn't have to be visually, but from a command line, you can use commands that support the Git flow workflow.
But if you're sold, wait until we get through the rest of these workflows.
You should wait. Yeah.
You should wait. All right. Don't jump off your bike right now and go do this. Right. Just wait a few minutes.
Keep pedaling.
Yes.
And a lot of the graphical tools are kind of biased towards this, like even if they aren't specifically designed for it. So some of the graphical ones like just don't look so good if you've got long-lived branches. And a lot of tools don't handle tags very well too. So it's just not.
Yeah.
Tags kind of stink if you have a lot of them. It's great if you have a few.
So again, similar to feature branch, master should theoretically only have stable code. And this workflow also allows you to split up your teams in such a way that you can have one team polish the release, for example, while another team is working on features, or teams are working on features for the next release, right? As well as you can have hotfix in your hotfix branches, you can have a different team that's addressing production critical issues without disrupting the other teams that are trying to polish that build or develop those new features, right? Atlassian, in some of their documentation that they had regarding this, they actually referred to this hot branch feature as a dedicated channel for hot fixes to production. I kind of like that terminology, the dedicated channel. And then I put this other pro here, and this is going to make a lot more sense now, but consider this an earworm. No commits left behind. So, consider that an advantage of this workflow. The cons.
One stream, right?
I'm sorry?
You kind of have like this one stream. Like master is your master stream. You have one kind of thing that everything kind of breaks off of and goes back into.
Yes, eventually.
Yeah. And in fact, a lot of articles that you'll read about Git and see about Git when you see. Well, okay, let me rephrase that. I'm going to assume that you read a lot of articles about Git
daily. It's my morning wake up.
I know. I've read more than my fair share, and you often see a lot of like they're called the subway line drawings for it, and there's some really pretty ones that try to describe the Git flow workflow. But let's go over some of the cons for it. So this does not work well for projects that need to support multiple versions concurrently. So if, for example, let's say that you worked at Microsoft and you were supporting all currently supported versions of Microsoft Windows, this would not be an ideal workflow for you.
Trust us. This is true. So the extra con to this workflow in that regard would be welcome to merge hell, population U. Man, this is no joke. Like seriously, we The three of us have tried this workflow on something that required multiple versions, and your daily life was literally just fighting merge conflicts.
It was definitely some lessons learned.
And it's demoralizing. Like,
I mean,
literally.
it worked fine for a while. It worked fine until it didn't.
And then it's like, you're looking at the edge of the abyss and then you jump off into it. Like, there was literally just a sharp drop off of productivity once you cross that line.
Actually, I can tell you, like, when I say that it worked fine until it didn't, as soon as I said that, it dawned on me. It's like, oh yeah, because in the beginning we didn't have a lot of versions to support concurrently.
Right.
But then as those backlog of versions that we had to support built up, that's where it started becoming like, when you only had like, you had the first version out there, and you're like, woohoo! And then, you have two versions, you're like, okay, well, I mean, how often am I really going to have to feel this pain? And then, the third one comes along, you're, oh man.
Yeah, because you're constantly making these changes to each version, and this flow doesn't work for it. Now,
No,
this flow is awesome, like he said, when you have a product that is always the latest that you're working on, right? This flow works great for that. But as soon as you step into the world of, you've got several versions of iOS that you need to make changes to, bug fixes, security fixes.
Yep.
You will just lose massive amounts of productivity.
As well as your mind.
And your mind. And the thing is, the problem is, if you Google this stuff, everybody will be like, use Git flow, right? Like, I think, Joe, you even said, like, everything you look for says this is the way. And that's a problem, because this is the way for very specific, probably a very popular use case, which is you have a product that you're constantly iterating on.
It's all about marketing, you see, and this one has a good name.
It really does. Git flow is beautiful.
And I think it probably works best for most companies these days that have like one website and that they, or like one kind of product that they're working on. But I was just trying to think of a good example of someone to the contrary, and I came up with Python. And Python's got the big 2, 7, and 3 split, right? But even in 3, there's 3.0, 3.1, 3.2, 3.4, 5, 6, 7. They're up to 3.7 now. So imagine if somebody finds a terrible security exploit in 2.7 and it got carried over into the version 3s. Then this security fix needs to get applied in 2.7, latest 2.7, and then in 3.1 and 3.2 and 3.3, 3.4, because those typically have different release structures. And if you've got code that works on 3.4, you may not want to upgrade to 3.6. And some languages will deal with that by saying, like, you have to go up to 3.7, but not usually. That's a pretty big dot change. Like, people don't typically willy-nilly upgrade something from like a 3.1 to a 3.7.
Right.
So that's the case where you don't want to have 15 tags for this thing.
Yeah, and I know we're doing a bunch of on this. Again, nothing against this. It works great if you have that use case, right? So just keep that in mind.
Yeah. So again, I think to sum it up, like, in my personal opinion, like, if you only have like the one version you need to support, this is a great workflow for that. But I also wrote, like, in the like, when should the season to Git guru use this? Like, you're familiar with all the commands, and you're getting familiar with all the different workflows. Like, when should you pick this one? This works really well for projects where you tend to only roll forward. And by what I mean by that is, if you never have a situation where you have to roll back, then this works great. If you have to, like, roll back through like previous versions, then maybe not so much. But if you're always just rolling forward with your feature changes, or your repository, if you're able to just, like, oh, there was a problem, okay, well, I'll just fix it in a hotfix, and then we'll just deploy the next master as soon as that hotfix is merged in. This is a great workflow for that. So it definitely has its place.
Yeah.
And can you imagine the Git commit merge conflicts trying to go from like 2.7 to 3.0 of Python? Good
man.
luck. And then even like getting from 3.0 to 3.7 without any conflicts. Yeah, right.
Yeah.
Well, that's why I put the merge hell, population U joke in there, because it's like, it's really not a joke. It's really like, if you are in that situation, this will cause you some pain.
And it's literally all day, every day, it feels like. every time you go to make a change, you're like, oh, please, like it's rolling the dice.
And I can't reiterate what Alan said. We're not trying to hate on this workflow. This workflow is awesome for its purposes, but if you try to use it for things that it's not intended for, you will regret it.
Yeah, I think that's really the takeaway from this episode at the end of it, and hopefully you're getting that now, is do not, this idiom's used a lot, don't try and shove a square peg into a round hole on this one. Don't do it. It's not worth it.
All of these workflows have their place.
Yes.
If you've ever Googled how to do a pull request from a tag into a tag, then you might want to consider a different workflow.
Is that your tip of the week?
Tip of the week.
That's awesome.
All right.
All right. So, hey, let's take a quick moment to ask you to leave us a review, because we really appreciate it. And if you've done it already, we really appreciate it. It's a huge help to us. And if you haven't, if you could take a moment and do it on like Stitcher or iTunes, that really helps us kind of find and grow and do our thing. So we really appreciate it. And if you could just go to codingblocks.net/review, try to make it really easy for you. And don't be afraid to tell a friend. They actually say that's the best way to kind of spread and grow. So if you've got a friend or a coworker that you think would be interested in the show, then you should tell them to check it out.
Check it out.
Just walk in the room. Check it out. All right. So let's get into my favorite portion of the show. Survey says. All right. So last episode we asked, what's your preferred password manager? We can't do that.
Wow.
Because we're recording ahead of time. So for those listening now, you're like, wait a minute, Michael, you can't do that. And I would say you're right. You're right.
Oh.
That's why I actually clicked on the poll results for the wrong one. So instead, I'm going to skip last episode's poll survey, and we will come back to that next episode.
Oh, that's
you're gonna have to be wondering.
Yeah, and you're going to be thinking like, wait a minute, how long ago did they record this? You'll never know.
That's right. Oh, that's a beautiful catch, man.
Well,
wait a minute, these don't match on my screen. Why are my eyeballs tricking me?
it's like, why do we have 0 votes? Oh, we haven't published this one yet.
That's right.
All right.
So much for a buffer. Well, we tried, guys. We tried.
So,
Consistency be damned.
so eventual consistency.
Yes.
So this survey, we ask, what's your social platform of choice? And your choices are Facebook for the old world, or Twitter. It's the best way to catch up on my covfefe. Or Snapchat, because a picture is worth 1,000 words. Or Instagram, because a picture is worth 1,000 hashtags. Or LinkedIn, it's all about keeping it profesh. Or Google Plus, I like the dust and cobwebs. And lastly, social. Get off my lawn, kid. What, you want the government to know everything about you? I tried to do my best old guy curmudgeon voice there. I don't know if it worked.
You're there, man. You're there.
Oh, really? Might have pulled that off.
Pretty good. Yeah, and hey, that's a reminder. If you send me a LinkedIn Ponzi scheme invite, I will accept you eventually next time I log in.
Same here.
Yep.
You guys must have like everybody. We won't even bother.
Yeah, we got a few. Oh, man. All right, so jumping back into this, we just finished up with Git Flow. Now it's time to talk about this fork and merge and how this one works. So this one's kind of interesting. This one, rather than everybody working off the same centralized repository, every developer gets their own server-side repo to work on. And you'll almost always see this in the open source communities, the GitHubs, the Git buckets, those kind of things. This is where you're going to see this forking strategy. So what this does is this avoids everybody pushing code to the same central repository. So rather than that, developers make changes in their own repo, and when they're ready, they submit a pull request from their repository over to the primary repository that they forked from. And this is basically exactly what GitHub does on everything.
And that's really important for a few reasons. One of the most important, I think, is that a lot of times if you're making a change to an open source library, it's because you need that change. And so you want to go ahead and get that rolled into your own code. So you kind of fork the repository, you make your change in there, you update your stuff. So now it's using the updated library. But in the meantime, you want to contribute that change back to the owners. And this is a great pattern for doing that. This is not going to work well with something like a Git flow where you can try to figure out like, well, should this be a hotfix or should it, like, as an individual contributor, if you're not on the collaborator list or whatever for that repository, you probably don't have a vote in that. And so that's not really an option for you. But I think a big part of the reason that GitHub got so popular and along with it Git is because it worked out really well for open source communities. This fork and merge strategy was a huge part of making code available and social.
Yep. And there's a couple of key points here. So when you say forked, that's the same thing as a Git clone. There's no special sauce happening under the covers. When you do a fork behind the scenes, it's just Git cloning that same repository into another named repo on the server. So if you think about that, there's nothing crazy going on behind the covers. That's it, except it's yours now, and it's a copy of that original. Typically, when you're doing this fork method here, you'll have two upstreams. So I mentioned earlier that by convention or default, when you point to origin, when we were talking about the branch workflow,
I want to call them two remotes.
Okay, two remotes. The origin used to point to the central repository. When you do this fork method, though, the origin is going to point to your repository. And then you'll have another one called upstream that would be the primary that you forked off of. And what that allows you to do is when you have both of these remotes set up is anytime you make changes, you're pushing to your origin, right? Anytime you want to pull in the latest changes from the original repository, you're going to pull that from upstream. And so that allows you to keep your code in sync with what the original repository was. And then when everything's ready to go, then you're going to make your pull request from there on over. Excuse me. And then actually, I think that was it for that. So the example here, and I think I put on names on this one just because it's fun. So let's say that you have your original repository. Yeah, you've got coding blocks repo, right? Now Billy Bob comes along and he's going to fork the coding blocks repo, which is basically creating a copy of the coding blocks one on the server side, and that's now his new personal one that he can mess with, but it's still public, right? So the coding blocks repo is public, so is his, but it's his personal one that he can work on, and he's the only one that has rights to it. So then he's going to Git clone that newly forked repo to bring it down locally so he can make some changes to it. He's going to commit those and then push those changes up to his forked repo, so to origin, right? And then after he's done with that stuff, he'll make a pull request from his forked repository back to the primary coding blocks repo. And then at that point, the cool part is this can also open up discussion. Like Joe said, one of the big reasons why GitHub got so popular is you put that pull request in. Now the maintainer of the original repo can go take a look at it, and he can start chatting with you about the changes, right? Like, oh, I like what you did here, or no, I don't think that'll work because we have some changes that are about to come in, whatever. It opens up the door to people being able to discuss the code. Once that guy gets that one and he's good with it, he's going to pull it down to his local, the maintainer of the original repo. He's going to merge it into his master, and then he's going to push that up. And then that's how your changes will get into the original repository. So that's the flow of this one. And really the pro of it is, there's two, and I should list the other one. One, it keeps the repositories nice and clean because you're not getting a ton of commits coming in just randomly and getting in there. Basically, once you're done with your body of work, you're going to do a pull request on over, and then that guy can pull it in and decide whether or not to bring it in or not. The other thing, too, is it also limits the number of people that have access to your repository, right? So I think that was the other big reason why it became so popular in the open source community is you don't have to worry about giving 1,000 people access to your repo. Hey, go fork it, make the changes that you want, and when you're done, send me a pull request, and I'll decide whether or not this should make it in or not. Really, the only con that I could see to this, in terms of just how this works, is it's a little bit more work than regular flows, right? I mean, it's a little bit more convoluted in that you're making a copy of the repo. I guess another con, that if I could come up with one, is I would venture to say there's tons of forks sitting out there that never had anything done to them whatsoever, right? There's probably just tons of copies of code laying around that. Well, I guess the way that Git works, though, is probably just pointing to I don't know.
No, because you have it would be a separate.
It would be a separate, so it is space.
Copy.
Yeah, so
I mean, it wouldn't be the server-side copy of the repo isn't going to look like what you're going to have locally. You're only going to have the compressed, binary representation of it.
It should be small, but other than that, I mean, it works out really well, and that's that. I guess to the point is, when should a seasoned guru, Git guru, use this? If you're contributing to open source, that's about the only time you're going to see this flow.
Yeah, and
or
also,
I could add. I'm sorry, Joe. I could add one more to that. Too, is like when you might want to use this is if you truly wanted to. If you wanted to base your functionality on something that already existed, but you wanted to go in a different direction,
that's a good point.
You could do that. So WebKit might be a great example of that.
But you're not typically going to push those back to the main repo, right? Like you're going to
That's
fork
what I'm saying.
that.
Like
Okay.
you're going to fork the repo
Just so you can use it.
and then you're never going back.
Okay.
So instead of there's no fork and merge, it's just fork. And done.
Fork and leaving.
Yeah. And we're out.
Yeah.
Yeah, and I wanted to mention, so QIT's got 13 collaborators. So you can imagine if those weren't officially collaborators on the project, then there would be 12 other forks sitting in GitHub of this project. So if somebody Googles for it, there's a good chance they're not going to find the original. So that kind of stinks. Actually, GitHub shows me the number of forks. That's pretty cool. I can actually go see who's got forks. So there already are 14 forks of it. But it just kind of muddies the water. You can imagine there's like 14 copies of this thing floating around. And I think that's the way it's kind of got to be for the most part. But just kind of interesting.
Cool.
So yeah, I mean, wildly popular. This one's heavily utilized. Great for very large open source projects. I think, like you said, you can't stress enough the ability of or the pro of it limiting who has right access to the main repository. Whatever you deem the main repository. And it's important to note too that what we're calling the main repository, technically there's no difference there. It's only the quote main or official repository by convention, but that's it. There's nothing technical about it that signifies it to be different than the others. Except
that's where people are going to be forking from the most, right? More than likely. That's really about the only way that you'd see it. But I mean, you could totally see like your WebKit thing, right? Like let's say that for whatever reason, my version of WebKit became super popular and people wanted to fork off that. I could probably have more forks off my repo than the main WebKit does. So that's even suspect, really.
Oh, I never really thought about this, but like the Linux kernel is a great example of something that uses multiple concurrent releases, and it's also a big open source project. So you can imagine where somebody's comes in and they try to add a feature to the kernel 3.0 because that's the one that they use or whatever. And I would think as like a Linux, if I was a collaborator on the project, I would see that and be like, oh, it's great you got in 3.0, but I'm not going to bring something into just 3.0. Either it's going to be 3.0 and everything up, or else put it in the latest version if it's not important. But it does put a big onus on any sort of contributor there. It's like, oh, you can't just sneak something into the backlog. It's either got to be current or you got a lot of work to do.
Interesting.
I wonder what kind of branching strategy they use for the Linux kernel.
Well, for both the Linux kernel and Git, we're not actually, it's not necessarily the branching strategy. I'm not answering that question, but they use the patch feature of Git that we're not even talking about.
Right.
There's no pull request. It's like submit your patch there, and they'll include, even in the Git repository that's on GitHub, they have the email address listed there as git at, what would that be? BGER, I don't know if that's supposed to be pronounced, but .kernel.org, and where you can submit your patch to. So you just email your patch in, and then they'll evaluate it from that way. So it's a totally different workflow.
Right.
It seems crazy, but I guess like you want to see it all in one place. And if you've got 3 months worth of work in the one patch and it's a ton of files, it's probably not going to get in because who's got the time to evaluate that? So unless it's like a serious problem, then chances are you're not going to get in. Like you need to get those things in bite-sized chunks. And I imagine they probably get like emails every day with patches that are, like Bitcoin miners or whatever.
Right.
Yeah, I gotta imagine that would be a massive undertaking to keep up with that inbox. Which pull requests do you like care about and which do you not? So, all right.
Default to not. Like you better do a really good job with that opening letter if you want to get something in the Linux kernel.
Yeah, your subject line better be really good.
Yeah.
This is not spam. Oh, that probably wouldn't work.
Yeah, probably not.
All right. So those are the main workflows that you see a lot. But there's one that I don't really know how we can name it. I mean, we put like 2 different names here for it in the show notes, but one of the names we called it was Microsoft's recommendations, and then another one was Microsoft's branching guidance. And I did that one kind of based off of an article of the same name that they wrote on. They wrote about this. And basically a friend of ours pointed this article out to me, and because I was really kind of like maybe bullish against some use of some commands, right? So that this particular workflow relies on. But after reading this article, it really changed my world. So how this workflow works. So this is going to be similar to Git flow in that this Microsoft's branching guidance will use a release branches, right? So plural, to track the releases. The biggest difference with this strategy compared to the other workflows, well, there's a couple. One, you will have long-lived branches, so I should have said that. But the maybe like the biggest one that you'd be like the most happy about, especially coming from some of the other ones, is the lack of merging that will happen in this workflow.
Stick with us. This sounds bad.
Yep.
But stick with us.
Definitely. Hang in there. We're almost through it. We can get through this. Okay, so similar to a feature branching workflow, you're going to create your feature branches based off of master, and then when you're done with those branches, you'll merge those back into master. And these feature branches are the only branches that are going to get merged, right? So right away, keeping up with what we said at the beginning, we're talking about small branches, right? These should be small things. They're getting merged frequently. So, already our chances for merge conflicts have lessened, right? Maybe not completely gone away, but we're definitely lessening the need for it. Then when it's time for a release, we will create a new release branch for that version off of master, and release the version will be part of the name. Now this is where Joe's strategy for the prefixing your branch names comes in really nice, because depending on your tooling, if you create your release branches with, say, a release / prefix, and so you do like release / 1.0.0.0 and release / 1.0.0.1, and then release / 2.0.0.0, etc. Then depending on your tooling, you'll have this nice little folder called release, and then when you expand it, you'll see all of those versions right there. And it really is pretty, in some of the tools. So and it really helps to consolidate some of those branches that you might otherwise have. All right. Now, any fixes that you have to make to a release, Unlike our Git flow where we would create a hotfix branch, instead what we're going to do is we'll create the branch based off of whatever release we're trying to fix and merge that fix back into that branch, same as what we would do with the kind of treating it similar to as a feature branch in that case. But here's the big difference. We're going to cherry pick the commit to any other released versions that need to include that, right? Or any other place that we need to have that fix, including maybe master, if the fix is applicable in that situation to that environment, right?
So basically what you just said, though, is you've got release version 1, release version 1.1, release version 2, right? If you make a change to release version 1 or a hot fix, you would branch off version 1, off release/version 1, make your hot fix to that, merge it in, and then after you do that, you're going to cherry pick those commits into version 1.1 if it applies there, version 2.0 if it applies there, and potentially even into master.
Yes.
If it applies.
Say again?
If it applies there.
If
Yes.
it applies to master, yes.
You're very, like, at a granular level, you're saying, I want these guys over here, these guys over there, and these guys over there. And I'm going to skip that one.
Yep. So right away, we're not even worrying about tagging our versions like we were with Git Flow, because instead we're using these long-lived branches to represent our versions. You still can tag if you really wanted to, but I mean, you don't really have a need for it necessarily. I can't really think of why I might be inclined to, I guess, is the way I would put that.
I agree.
Well,
So
I got one. So sometimes you want to get a specific version of something, like say you've got a customer that's got a specific version and you need to reproduce a problem. Then it's nice to know that they've got this particular tag and this is the particular tag I'm going to work on, because someone might have fixed it since if they're not up to date.
that could get hairy though as your number of customers scale. But I mean, I understand the intent of where you're going from. Basically, at that point, you're trying to use the Git tag as a history of which customers have which versions installed, which...
It doesn't have to be customer specific though. It could just be like a, 6.1.11. And like maybe you've got a 6.1 branch, but you don't necessarily keep a 1.1 branch, and a 1.2 branch, and a 1.3 branch. Just, I don't know if that's a good idea or not, but I would typically kind of think about things that way depending on your setup. Like, something like a Windows or a Python environment probably doesn't make sense to do that. You'd probably have a branch for each one. But if you've only got a couple of major branches, and sometimes, you can still have like customers or people kind of using it, like interstitial kind of versions of that branch, and they don't all get upgraded at the same time, which is especially relevant if you have like on-premise or white-labeled software. And I know that's really common. The guys at Complete Developer Podcast kind of talk about, they had a great episode on white-labeled software, which is like someone kind of takes your software and installs it somewhere, and it's like a snapshot of what that code is at the time, and it can kind of evolve from there. And that's a good case where you might have two people that are on a 6.1.11 and a 6.1.13, and if you're trying to track down a bug, it's important to know that you should be looking at the 6.11 because it might be something that you've already fixed or has changed.
That's fair.
Okay, I'll take that. So in regards to like the examples of how we're using this, like really the new thing that we've introduced here is, well, one, we've introduced more branches, more special branches, being that these are the long-lived release branches. But specifically in terms of commands, we're going to use the git cherry pick command. Now, if you're doing this from the command line, I typically like to include the -x parameter, which will automatically include in the commit message, hey, this commit was cherry picked from this other commit, and it'll automatically get the ID of that other thing for you and include it in there. It makes it easy to, like, when you look at it, and it'll include the previous commit message from that commit as well. So it makes it real easy to try to follow that. But it's kind of advanced to where if you're using something like a Visual Studio Team Services, they'll do this for you. Assuming that there's no conflicts, just straight from the UI, as soon as your commit is there, you can start cherry picking it into other branches, and they'll go so far as they will create branches for you that your commit goes into, and then they'll merge. They'll create a pull request for that branch into whatever destination you ultimately want.
It is stupid easy.
So awesome.
Yeah.
I mean, it's just great. So real quick, I want to go over the pros and cons of this thing, and then we can elaborate on it. But the cons, the pros of this workflow that Microsoft has here, no more merge hell. I mean, you're, like I said, you've really reduced the merging down to just the feature branches back into the develop option, or possibly the hotfix back into the release branch. But those should be small and easy. So for all practical intents and purposes, you've removed your merge woes. You, like Joe said, you get total control over which commits are going to get merged into which branches. So total power over that type of decision. So if there's maybe a feature, or let's just say a fix that wasn't applicable to a certain version, but maybe there was something else that was, then you can just pick the commits that you need and forget the others. Whereas with some of the merging from, say, a Git flow, it's an all or nothing, right? So going back to the use of the tags that the Git workflow, if we're going to heavily compare these two against each other, right? Git workflow used tags for the versions, but the tags you could often those like a commit, they're local to your environment until you push them up, right? So with this workflow, there's no more, I forgot to push the latest tag up. That type of issue goes away. And this workflow works extremely well for large projects and large teams where there's frequent or extremely often, the cadence is high, I should say, on this. It works great for that. It works great for projects where there's multiple versions that need to be supported, because it allows you to easily keep those long-lived branches out there until you no longer need to support it, then you can just delete the branch. But as long as you do need to maintain those, as far back as you need to go, if you need to make a change, you can just cherry pick it from the oldest branch all the way up to whatever the latest branch is that you need to support, which could be the latest, your latest master branch.
One thing we didn't really mention, I don't think we really went into it, the merge hell, is that if you're frequently merging from Python 3.0 to 3.1, you're going to handle a lot of the same merge conflicts over and over and over again. And that's a big part of the problem, because something will have changed and you need to keep it, but Git doesn't know that you've already merged this in over and over and over again. So you can get in this case where you're just constantly dealing with the same things, and it's a real big pain in the butt. And wanted to mention too that it seems like you wouldn't want to skip cherry picks that often, but it comes up a surprising number of times in practice, I think. And what it would be like is you'll have a problem with the feature in an older version. You'll fix that problem, but in the next version, that feature has changed in such a way that the fix either is no longer applicable or actually does more harm than good, because now the paradigm has shifted and now it drives better. And so you don't need that code change at all because it's good. You're just fixing something in an older version. And I think with something like Git flow, where you're constantly having to merge that in, you're just having to deal with the stuff over and over again. And it makes for some really awkward merge conflicts where you're this isn't a merge conflict as much as it is just an incompatibility that I have to code a custom solution to. So it seems like in practice for me, from what I've seen, that when supporting multiple concurrent releases, these recommendations have worked out really well.
I want to add too here. I think I said while I was describing some of the workflow around this Microsoft's branching guidance, I might have used the develop as the branch name, but really you don't need the develop branch in this scenario. You can just use master. So you'll just have everyone developing off of master, creating feature branches off of master, and release you'll have a whole section of release branches. So just to round out the cons here, you could easily forget to cherry pick a commit into any branch or specific branches that it needs to go into. Or maybe it's not that you forgot so much as you didn't even know. So, we said that the pro is you get total control over that, but that's also a big con, because in the Git workflow scenario, remember I said no commit is left behind, right? And that's what I was referring to, is that here in this scenario, you could easily forget to cherry pick that into a specific branch, or maybe you didn't know, right? So when would the seasoned Git guru use this particular workflow? And like we said, if you have to support multiple concurrent releases, this is a fantastic workflow for that. Oh, I did want to add too. I said that I was a little bit bullish about the commands that this uses, and I forgot to mention that at the time, that I was specifically referring to the Git cherry pick, because for a long time there, I just thought of it as a bad. It was more. I viewed it like I viewed your need for doing a cherry pick as more of like you didn't have a good workflow already lined up. Like it was making up for a lack of something, right? And that if you were doing the merges, then you didn't need it, right? And this article that a friend shared with me really changed my view on that, and so now I'm a big fan.
So, I mean, just a heads up on this. So we talked about earlier with GitFlow that it wasn't the perfect one for everything, right? This Microsoft strategy works very well. Like we were trying to use GitFlow with multiple versions of a product, and like it was not uncommon for all of us to be dealing with merge conflicts a good hour or two a day. Like it got to the point to where you literally hated being the guy putting a commit in that needed to go forward a branch somewhere or a version, because it was like, man, here we go. Here goes 2 hours of this. And since we switched to this Microsoft pattern, which, by the way, they might have a little bit of experience working with multiple versions of a product.
A little bit.
Maybe. Since we went to this, like, I remember the fear that everybody had was, well, people are going to forget to cherry pick their commits, right? That was the overarching thing that everybody kept saying, well, somebody's going to forget. And here's the funny part, right? Like anytime something new is introduced, you're going to hear a bunch of naysaying because people aren't familiar with it. They don't know it, whatever. Here's what we found out. First off, that doesn't happen that frequently, because when you're working in something, it's fresh on your mind. And it's really easy to say, okay, well, this needs to be in version 1, 1.1, and 1.2. I'm going to go ahead and do those. And like Mike said, if you're using something like Visual Studio Team Services, where they have this support baked in for it, after you merge in the first branch, it's like, hey, do you want to cherry pick this to somewhere else? And you click a button, then you choose the branch that you want it to go to. And it's almost like magic. It's kind of ridiculous how easy it is, assuming there's no conflict.
Yeah, but I think that sorry, go ahead.
The one last thing with this is, while everybody worried about forgetting to take these cherry picks further along, what you eventually find out is you're way sharper on doing those because you're not fighting merge conflicts so much. Because in the previous flow, when we were trying to cram our use cases into GitFlow, you literally spent a third of your day fighting merge conflicts as you merged big older branches into slightly newer, and it just got ridiculous. So when you go this route, it's so much easier that you're just sharper about getting those things done. So all the concerns we had literally went away. And I'd venture to say I can't think of the last time since we adopted this strategy that I've heard anybody like complain about the problems with merge conflicts. I don't recall any.
Yeah.
I think the UI has really been a huge part of that. I think if people had to use the command line, because a lot of tools don't have good support for it, I think that might be a different story. But it's so easy in Visual Studio Team Services to do that. But I did want to say too, like I think that part of the reason we haven't seen a lot of problems with it is because you're hyper aware of the branch you're working in. Like if you have a ticket for like a hot fix for some older version, like you already have to, like no matter what your strategy is, you have to know what to check out in order to do that. So you have to be on point and correct with where you're starting from. And when you're starting with an older branch, you're aware of it. You've already probably got some special setup type stuff. You don't forget about that, And so
Right.
I haven't really seen much of that after the kind of the initial kind of bumping heads on the paradigm. So I've been really happy with it overall. And I also wanted to mention, like, a good sign that you might want to take a look at the Microsoft recommendations is if you've ever created an interstitial branch. And you're going from like branch 3.0 to 3.1, and you keep hitting the same merge conflict so many times that someone just finally says, screw it, I'm making a 3.0 to 3.1 branch, and I will bring my changes from 3.0 into that branch where I've already resolved those merge conflicts, and then we'll move this one to that one, and we'll just keep this middle branch. And so what happens over time is that you've got 4 or 5 kind of tags out there, and now you've got these branches that are living in between these tags, and you've just got an explosion of stuff you're having to manage. And it's like this little kind of secret tribal knowledge that there's a secret branch that you can kind of merge to that helps you get your changes where you need them.
I forgot about that. That was a real pain. By the way, I don't actually use the visual tools. I almost exclusively do it all through the command line because it's so easy. I mean, like you said, get cherry pick. Say what?
Oh, and say easy.
No, it really is. So, I mean, here's the thing. Like almost all the UIs out there will let you copy the hash for a commit. Like one of the things that initially was a bit of a struggle because I just didn't know how the get cherry pick worked is if I had 3 or 4 commits, like I would try really hard to make sure that I only had one commit because it was like, oh man, how am I going to cherry pick multiple? Well, it's really easy if you do a get cherry pick -1 or -x, because I do the same thing. So it brings along that nice commit message saying that, hey, it got cherry picked from this branch. But then you can literally just paste multiple hashes after that, and it'll bring all those commits along in the cherry pick. So it's actually pretty easy. And I started doing it locally because it seemed like it was hit or miss whether or not if I did it through the UI, it would come back and say, hey, there's a conflict. And I'm like, man, okay, well, I'm going to have to do it locally anyways. So I just got to the point to where I didn't even mess with the UI anymore. I was like, you know what? I know that I need this particular commit or these set of commits in, version 1, 1.1, and 1.2. I'll just do it all locally, and then I'll just push up all 3 branches and then do pull requests from each one of them, right? So it's not hard. The get cherry pick method is not hard, and it can save you a decent amount of sanity and some hair, which
yeah, I did all that I got.
Yeah.
Well, I have a super pro here that I thought of that I didn't put in the notes for this workflow, and that is in the scenarios that you guys were describing where you're trying to use and I'll say it, like you're trying to use Git flow for something it wasn't designed for, right? By trying to support multiple concurrent released versions like that with those long-lived branches. Well, really, it's not even, I wouldn't even say it's a Git workflow or Git flow. It's kind of like a bastardized version of Git flow at that point. But when you do those merges and you hit that merge hell of one old, you have, let's say you have 3 released versions plus whatever your current master or developed branch is that you're working off of, and you make a fix in say version 1, and you need to carry that fix over to version 2 and then version 3 and then back into whatever your current master is. When you do that merge and you resolve all those merge conflicts, you're not only like dealing with your own code, but you're quite often like dealing with merge conflicts for code that you don't own either side of. Like when you have a merge conflict in your own code, like you write a commit or you write some code, you commit it, and then you merge in and there's conflicts, at least one side of the conflict you know about, right? And then the other thing is something else that somebody else did. you can try to figure out like, okay, well, I know what's going on here, and you have enough context that maybe you can go on without having to, work with someone else to figure out what was going on, or at least maybe you only have like one person to deal with. But in this scenario that you guys were describing with the version 1 to 2 to 3 kind of scenario, you more often than not are going to be trying to solve merge conflicts where you are not the author of either side of the conflict, that then you're going to go and try to track down, and then you're like, well, wait a minute, you guys fight it out, and then, I'm already in the process of merging this, so I guess just tell me which one to pick, or how to merge this, and then do it. But in this scenario where you're only cherry picking, then anytime there's a merge conflict, at least you're one of the authors.
Yeah, you're at least one half of that equation.
And because you just developed it, you're intimately aware of what you were trying to do.
Yeah, I mean, that's the thing. Like, going back to the Git flow, what you just said, the version 1 to version 2 to version 3, that's every single time somebody has a bug fix to version 1 that has to go all the way up the chain. You fight that same battle every time, and you lose your will to live or code or do anything.
Another important part of that, though, that like as soon as I said, because you just developed on it, you're intimately aware of it, that immediately sprung into my mind is that when you are going back through the version 1 to 2 to 3, and you're not the author of either side, and you're like, hey, Alan and Joe, you guys conflicted on this, and now you guys are scratching your head because it could be months ago.
Totally.
That you're like, well, I don't know why we did that or who did what for what reason. Like, now you two gotta like go back and try to remember.
Yeah, well, version 1 was released in 2016, and customer out there doesn't want to upgrade to version 2. So yeah, when you make that change to version 1 from 2016, now you're having to deal with code that is 2 years old, trying to figure out what I don't even know what that did anymore.
So I can't stress enough, like, for supporting multiple concurrent releases, how much easier this workflow is.
Yeah, man, and Outlaw's stress levels probably went way down because he's sort of like the Git guru that everybody goes to when they have a problem. And prior to adopting this strategy, like I'd venture to say that half of his days were filled up with people like, what do I do? I remember that. So it was horrible. Did we save the best for last, or is this just the best use case fits this one?
I mean, I wasn't trying to do it that way. I did. Okay, let me rephrase. I didn't structure the workflows in that particular order necessarily because I viewed this one as best necessarily, but I wanted to build the story, right? And so I felt like you needed to start with just a plain centralized one because that was just the bare bones simplest scenario, and then start building on those because everything or a lot of workflows build upon the feature branch, so you needed to know that. So it was just coincidental that it worked out, is what I'm trying to say.
Yep.
And to be honest, cherry pick is a hard sell. As soon as you realize that someone could just miss something, and it's really hard to kind of notice. And yeah, I think there's some tools and some commands you can kind of run to find that sort of stuff. But for the most part, it's probably not a mistake. And in practice, we've seen it work out really well. I also wanted to mention that in the multiple concurrent release world, if you are not doing something like the long-lived branches, then your automation is kind of in a weird spot. Because if you imagine, the Orange County public school system is on version 1.1, but Seminole County is on 1.2 because they needed some new library system or something of your code. And then you check in a fix in 1.1, you move to 1.2. What does your build automation look like for that? Is it looking for a tag to build and commit? Is it looking for, how do you hook that stuff onto to kind of run your tests and build that stuff for deployment? Like if you've got these long-lived versions, that's a business use case. That's not a Git thing. That's like your business. And so this works out really well for that. And so, like we said, like this isn't like the right way for everybody, but if you got multiple concurrent releases, then you owe it to yourself to check out these recommendations.
That's another good point, though. And another great way to say that, Joe, is that the workflow that you pick, you need to take a look at how your business works and how your business supports whatever its customers might be. And you need to pick a workflow that supports your customers and the business workflow.
Yeah.
Because if it doesn't align, then you're in trouble.
Yeah, and that will sort of line up with, I think, what you said, the continuous integration, the continuous delivery, right? Like if you need to support 5 versions of your product, you probably need to do something that makes that pretty painless, right? Because you don't want to be fighting your integration pipeline at all.
Or said another way, if you are trying to fool yourself into, well, we will only ever roll forward,
Right.
but the reality is the business side of the house is like, no, we support like 5 versions concurrently. And you're
Don't
like,
fight
no,
it.
we're going to roll forward. We're just always going to roll forward. That's where you're kidding yourself, and you're going to set yourself up for disaster.
Yeah, don't fight it. I mean, again, like all of these strategies have a place. Pick the one, and I think we've covered a pretty big swath of what types of problems you'd face in your source control world. Pick the one that suits your business needs the best,
Yeah, absolutely. And like we mentioned, a couple links in the show. We're going to have a bunch of links there, and the resources we like. Got some really good stuff in there comparing different workflows, and of course we'll have the links to the major ones and a couple of those opinions that we mentioned.
Yep. And so with that, we'll head into Alan's favorite portion of the show. It's the tip of the week.
Yeah, baby.
All right. So for my tip of the week, I thought I would share one that I found that I haven't had a need to use it myself.
Thank you.
So, but it does look like it would be a really cool and helpful resource. So if you want to ace your next coding interview, you can head to codeprep.io. And here they've got not only challenges, but they've also got like a whole series of interview questions that are, just interesting. Like, for example, if you wanted to see JavaScript questions, an example might be, what is hoisting in JavaScript? Provide an example, right? Things like that, like, jQuery questions, CSS, HTML questions. jQuery, why jQuery? Don't hate on jQuery.
Yeah, I'm leaving the site now.
But I mean, they're giving you some examples here, right? So, really cool resource. Check it out.
Dude, what in the world? So if you go there and then you hit the register button, it takes you to an IP address that's not secure. What? I can't believe you didn't vet your tip. Can't take it.
That must be a new issue.
I think this might just be a bootstrap template.
That's funny.
Okay.
All right, well, that failed.
Go ahead and go register and give your username and password away.
Well, don't use one that you care about. Never reuse your password. We already talked about password managers last episode. Don't reuse them.
Oh, man. Yeah. All right. So for mine, I totally copped out on this one because my brain was completely fried. So what I did is I went and found like a huge list of Git tips. So we'll have a link here. It's github.com/git-tips/tips. And there are so many here that I don't know how many of them are useful. There's literally so many. Like, I don't know how you would find, like, what you need to do is just skim this list. It's almost like documentation for coding for me. Like, if you ever get a third-party API that you're ever working with, do you guys do this? I'll literally skim through it all. Not read it, not try and grok any of it, but just skim through it all so that I'll see the things that are there so that when something comes up later, I'll be like, I saw that.
So basically what you're doing is with your mind, you're making an index of the content. So like, okay, I don't know what that says, but I know if I need to reference that thing, it's about a third of the way down the page.
No, seriously, it's just that, because there are times that you're like, I don't know what I don't know about this thing, so I don't even know what to search for. But if I saw it, then that keyword might jump back out my head. So treat this list like that is what I'm saying.
All right. Well, for my tip of the week, Julia, the language, just hit version 1.0, and it's been kind of rising very quickly in like the TIOBE indexes, those things that kind of track the most popular languages. And so I thought it might be an interesting time to go look at this language because people are still kind of building things, converting things from other languages, and just kind of a hot, cool space. And if you haven't looked at the actual syntax of it's actually pretty nice. It reminds you a lot of like JavaScript and Ruby and some other dynamic languages. But it's also got some features kind of like Go, and it's really supposed to be good for like mathematical and kind of precise mathematics and functional type stuff. But it just has some really nice conveniences of like a dynamic language. So it looks pretty cool, and now's the time to get into it if you are looking for something to get into.
And it's gaining some popularity in the machine learning world too.
Yep, and I guess MIT, it came from MIT, but I guess they're switching over a lot of their stuff, and so they're kind of pushing it because it's supposed to be easy to use like Python or JavaScript. It's supposed to be precise like, I guess like a functional, I don't know, language is precise like Prolog, or what's the one I'm thinking of?
Haskell?
Not Haskell. What's the old school, like Fortran? That's what I was thinking.
Yeah.
Fortran is still kind of popular, and like R, it's got some nice stuff for doing like cool mathematics type stuff. It's got multiple return types like Go, and so it just looks nice. It's got options for types.
Am I the only one that was hoping that we would like just randomly continue to randomly throw out programming languages until Joe was like, "That's the one." Like that ended a little too quick.
Lisp.
Okay.
Very nice.
Yeah, check it out. Check it out.
That's our new Coding Blocks catchphrase.
That's
CodingBlocks.net. Check it out. All right. So with that, subscribe to us on iTunes, Stitcher, and more using your favorite podcast app. And as Joe mentioned earlier, if you haven't already, we would greatly appreciate if you left us a review. You can find some helpful links at www.codingblocks.net/review. And don't be afraid to tell a friend.
That's right. And while you're up there on the site, check out all our show notes, examples, discussions, and more.
And send your feedback, questions, and rants to the Slack channel at codingblocks.slack.com. You can sign up for it at codingblocks.net/Slack. And make sure to follow us on Instagram and Snapshot and what was it? Elephant, Mastodon, and everywhere else.
Instabook, Facegram.
There we go.
Tweet in.
Yeah, if you just go to codingblocks.net and look at the top of the page, we got links to all sorts of stuff, so we can interact wherever you probably feel like interacting.
Yeah, Link Plus, Google in. We're there.
Google in. The snapshot.